Okay, we're good, right?
Okay, we are good. Welcome, Jeff. How are you doing today?
Crash course in Twitch and Discord and Zoom.
Oh man, we didn't mean to do all of that to you simultaneously. I'm so sorry. But you're here now. You're here now.
So I'm getting like a super delayed secondary thing.
You have Twitch open somewhere on your computer. You
Oh,
need to
I
close
do.
Twitch.
Hold on. That's okay. All right, so I'm going to take this. There we go. All right.
Yep, you made
Okay.
it. You're
Here we
here.
got quiet, but it was just you and me now. I see. Oh,
Yeah. So
oh,
welcome. You
thank
you
you.
are one of our longtime community members, and I'm so pleased that you were able to join us and that you reached out over Twitter and made this happen. So tell our audience a little bit about yourself.
Well, I'm connected to the 365 Days in Astronomy because I was actually the first podcast that was published after your introductory one.
Oh man, I'd
Way back
forgotten
in,
that.
yeah. How do you
Back in
know buying your first telescope?
2009.
Yeah.
And you stayed with us for, I want to say we still have episodes from you, but I don't know if they're redos because my brain is terrible.
The redos.
Okay, they are redos. That's what I thought.
It's one of those I should get back into doing it, and I haven't. So
Well, life gets busy, and 10 years is a long time to stick with anything. And
yes, it is.
you're still part of the community, and that in a lot of ways matters most.
Oh, well, that's good. Thank you.
Now, what what lured you into 365 Days of Astronomy originally?
Well, I thought, okay, I have a small cat here named Muppet, and he's the cat that doesn't want to come up. He just wants to grab my arm and say, pet me on the floor. So,
That's all right. Eddie just like
arm.
totally nosed me repeatedly until I scratched his shoulders.
So I thought that, well, first of all, IYA as a whole concept was super awesome.
Yeah.
And it actually did a lot of things for our local astronomy community here in Wisconsin as well.
Uh-huh.
Um, and then 365 Days of Astronomy, I'd never done a podcast before. And I thought it would be really interesting to try it. And I just submitted one, and then you guys took it and sent it out.
And
So,
life is good. Life is
yeah.
good. And that first year, I'm going to keep showing this off.
Oh,
We won this our first year as a community. This is our Parsec Award for Best Infotainment Cast. And you were part of that. And so
yeah.
thank you. Now, you are still engaged in astronomy. What all do you do to, well, feed your passion?
Well, I mean, currently I'm doing some 3D printing projects. I'm president of our local astronomy club for a long time, and whatever. We do a lot of outreach, about 30 to 40 events a year. And a couple of years ago, I noticed that people want to take pictures of the moon through their telescope. So a friend of mine and I, we thought, well, there's these adapters that you got to kind of like, if there's a line of like 10 people, it's not super fast to do it.
Yeah.
So I developed one that basically just sits on an eyepiece. It's made for the eyepiece, and you just basically slap your phone onto it. It gives the right distance from the eyepiece, and
Oh,
I got to
sweet.
do X, Y right there, and then do it. I did it for one of my personal scopes a couple of years ago. I've done it for AWB1 Sky. I've done it for the library with Doug Aaron, and we're going to do one for the Galileo scope.
That
So
is
it's just
awesome.
a 3D printable thing. Just download the file and 3D print it like at your local whatever makerspace, or you can order them online from different services.
Now, with 3D printing, one of the things that I'm really loving about the 3D printing community is people share their patterns. Can people go find your patterns, or are you part of getting everyone's telescopes iPhone ready?
Yeah, so it's kind of a thing that I started for my work. So we do CAD and 3D printing stuff, and I need projects for a video, and I just kind of, this is an excuse to do this. So I did, and then I just piggybacked it. So if you actually, I convinced our company, we actually have a website, and it actually has all of the all the articles for all the projects I've done, and you can download all the files for free.
That is awesome. Can
So
you share the URL?
yeah, how do I do that, like electronically, or do I
Just
just tell
say it
you?
out loud and we will
Oh,
magically type it in.
well, it's a little long, but it's www.gsc, that's Gary Sam Charlie dash 3d.com.
Got
And
it.
what you do is you go there. That's our company website. You go to the article resources, articles, and then you kind of have to go to like last year's articles. You'll find it's called Digiscope Adapter for AWB One Sky, and there's a couple others. So we're working on redoing our company webpage, and when we do that, I've been told that I will be able to just have my own landing page for all of these things. So
That
people, the idea is just to have like, you have this eyepiece, this is what you want. This eyepiece, it's based on the eyepiece, not the telescope necessarily, because it's just about the size, and they're all custom made for to fit exactly that eyepiece. So you don't have to adjust anything. You just kind of drop it on your eyepiece, and you go. So eventually there'll be a universal web page for everything. But the one for the One Sky is there, and you can see the related articles after that.
okay. So I went to your website. I then click on what?
Resources, and then
Okay.
articles, and then articles.
There we go.
And then you got to go like you got to scroll down, and I think it's last year. It was like late 2018 is when this last one was out there.
Okay. Our audience will be able to find it and share the links out. Somebody else already got it.
Okay, sounds
So
good. Yeah.
I can bring it up on screen to share. And Astronomers Without Borders is such a great project. We've been sharing about their scope all day. I have one of them downstairs. And how did you first hear about this little tabletop scope?
Well, I'm a fan of AWB as well, and sort of, I got one of my own, of course, because I collect scopes, so it's kind of happened anyway.
Yeah.
And we've had it for a couple of years, but then when we were looking at our company, we work with a CAD company, and they do a customer spotlight every year. And one of the customers is Canada, France, Hawaii Telescope.
Oh, geez.
They're redoing their 3.6 meter, and they're making an 11 and a quarter meter. It's called the Mauna Kea Spectroscopic Explorer. So the whole rolled out the whole, hey, all you engineers out here, here's your new software, and here's our 2-hour knockdown, drag out all the technical stuff. The data set is the CFHT, the new observatory and telescope and everything. So recognizing the opportunity, I'm like, hey, we should have door prizes at these things.
Yeah.
We should have a raffle for everyone to win a telescope at each of the 7 events. And let's do AWB's One Sky because it goes a good cause, and we did that. So this sort of rolled on. If you look at the video that's in this article, basically it talks a little bit about that and what happened there. But it's just this confluence of my vocation and avocation sort of happened the last 18 months quite a lot. And, I'm doing everything I can to extend that.
And SolidWorks does some really neat stuff. And this ability that you can pilot something on your local 3D printer. You can then scale it up. You can reach out to have other companies mass produce. And you can so cheaply change designs as you need. And it gives us a new way to constantly adapt our technology. At one point when I was working at a not to be disclosed East Coast major university, the 16-inch telescope by a company I won't name that is not Celestron, the telescope, the mirror got such that every time I tried to focus the scope, instead of moving the entire mirror in and out, it would tilt the mirror because the focus only put one point of pressure that was off center on the mirror. Right. And so it got to the point where we had to just lock the mirror in place, and the only way we could focus was by moving our detector in and out. So we set it up so that it worked fine with the CCD, but then you couldn't use an eyepiece because We just didn't have the extender that we needed. Now, with
Hmm.
the 3D printer, which we did not have, we could have just printed that extender and been done with it. And would
And
have,
the thing is, the materials are amazing. So at work, we've had the plastic ones, the typical ones you see. You can spend thousands of dollars, even hundreds of dollars on the basically the hot glue gun with the draws little
yes.
melted ABS or PLA. What we have now at our place is also chopped carbon fiber mixed in with a nylon matrix.
Uh huh.
So all the eyepiece adapters I'm printing now are like super way stronger than they need to be because it's just the cheapest material we have now, all the way through a secondary fiber reinforcement, continuous fiber of carbon fiber, nylon, or Kevlar. So you can
Kevlar?
yep. Mm-hmm. And the other thing we can do is metal, stainless steel and tool steel right now. So we can actually make not big parts, but we can do metals as well at my office. So as I go and say, I have a broken tripod clamp on my Classic 8, that means I can't extend my legs because it's just a broken clamp. Well, what I'm going to do is I'm going to design a new one, and print it out in this nylon matrix with chopped carbon fiber, and I'm going to reinforce with Kevlar, so it'll actually be a nice functional clamp. So, I mean, we're actually at the point now where it's not just 3D printing, it's additive manufacturing. We're doing actual production parts. These are printers that companies would use to make tooling directly.
That is amazing. We're going to keep
So, yeah.
talking,
Mm-hmm.
but someone just donated bits and I was
Oh,
attacked by a dog. So there's going to be a dog on camera in just a moment.
okay.
Now, so I work for the Planetary. Come on here. Come over here. Come over here. I work for the Planetary Science Institute, and you need to come around, little dog. Come here. Come around. Come on up. And we have a 3D printer at work. Come here. We actually have two of them, and they've recently set them up so that there's a Twitch channel dedicated to the 3D printers. And come here. Come on. You can come on up. Sorry, the dog is threatening the life of everything.
Yeah, I see.
And the other dog is underneath. I'm just going to hurl Cheerios to the other side of the room while we chat. So for those of you who don't know what's going on, we thank you for your bits and your subs and your Patreon support. The best way we know how, which is with cuteness and doggos. So I am hurling Cheerios, and the doggos are now vacuuming them up. So with the Planetary Science Institute, we have our two 3D printers, and what we end up doing with them quite often is printing shape models of asteroids and comets. And as you discussed, the fact that you can now 3D print things out of Kevlar, the first thing that came to mind was printing bulletproof comets. And I don't think there's any need for bulletproof comets, but it occurs to me that this is a thing you have the capacity to print.
I don't know if the matrix, the way we do it, is bulletproof, but it definitely has the reinforcement properties and the strength and the tensile strength of it's a Kevlar secondary. So imagine a regular 3D printer, but instead of ABS, we're printing nylon with lots of little chopped up carbon fiber bits in it just to make it generally stronger. But then as we lay down the layers, there's a secondary spool that's stringing a continuous fiber, which can be carbon or can be Kevlar. So I don't know if the matrix would be bulletproof because of the way it would print it, but it's definitely strong and resilient and all that kind of stuff. So industrial strength wheel parts, clamping, tooling, fixtures, that kind of stuff. But for me, telescope parts, broken telescope part, boom. That's the fun. That's a fun part of it. And I get to kind of combine this because, again, if you follow me on Twitter, I know you do.
Yeah.
At SolidWorks World, the big annual convention, like the AAS kind of thing every year.
Yeah.
There's nothing but telescopes all over the place. And, the I nerd out for little badge, you write your own what you nerd out for. I said telescopes. And
Yeah.
And when I wrote that, everyone knew what that was now, because it's the CFHT data set. So Greg Green from the CFHT Institute was out there. He did a presentation on what they did. And so it's just kind of combining all this stuff together. And because of that, on Twitter, I've been doing a lot of connections with these institutions, with these observatories. And it turns out that this software that we represent, SolidWorks, is used in just about every telescope, observatory, and whether it's ground-based or orbital telescope there is. So I get to, like, as part of my job, say, oh, Sophia, for example, which that was designed in SolidWorks. CFHT, CAC is designed in SolidWorks. They're using it. So every time they post something, like design SolidWorks, or there's a free version of the CAD tool called Apps for Kids, and every Telescope Tuesday online, I make a little thing with this free little modeler that it's designed for kids, and I made an astroscan. I made a one sky telescope in there, and the last time I made a little version of the Great Magellan Telescope, which is Giant Magellan Telescope, was also being designed in SolidWorks. So I get to do this as part of my job. Like, it's like, okay, I should do this for like a half an hour and make a little telescope and then tweet it, and it's so I get to help to spread telescope and astronomy knowledge in just general engineering type and business world now, in ways that I just happen to fall into place. So it's like outreach, but in different places and unexpected places.
That is cool. And one of the things I love about 3D printing is you can make the surfaces of other worlds visible to people who don't have vision. It's a kitty.
His name is Muppet. Like,
and that's how cats most like to present
yeah,
themselves.
that's right. Hello world. Okay, now he's
And then
done.
straight over. It's what cats do. So have you printed out like a section of the moon or one of these asteroid models or anything to share with Sidewalk Astronomy?
See, I haven't done that yet, but I have another type of printer we have is
Uh-huh.
a high volume printer from Hewlett Packard, which is
Uh-huh.
like, think of like powdered plastic that's sintered, and it has a build volume of 14 inches by 14
Oh,
inches. So, having worked with Yerkes Observatory, I data that group down there for years because, again, I'm a Wisconsinite. Um, I know they did a lot of tactile astronomy aids, like a
yeah.
picture of a galaxy, but in tactile form and that kind of thing. So I've kind of thought, with the new HP one, which is much less expensive, just plastic, very high speed, I'm
Yeah.
thinking of doing some of those. Give me a whole set of the asteroids, because I could print like 8 of them in like an hour and a half.
We
Just
would be happy
print
with
it out.
at the Planetary Science Institute to help you get those shape models. And we have asteroids and comets, and we just want to get them into people's hands.
Yeah, absolutely. Because that's, in Wisconsin, it's cloudy sometimes. So if it's cloudy, hang around the telescope and observatory or whatever and talk and whatever. But it'd be great to have some of those tactile hands-on things to talk about. And I've seen them online, but I haven't gotten around to printing yet. But I think because they're looking for stuff to print, they're like, hey, we need models to print. I'm like, I think I can help you there. If you ask me, be careful what you wish for, because I'm pretty sure I'm going to come up with a lot of things to print.
That that is awesome. So, pardon me while I'm looking in a strange direction. We are having a transition in our behind the scenes staff, and I have to give a shout out to all the mods and all the wonderful humans who are out there. From Annie, who has joined me in my attic, to Susie, Nancy, Paranor, Keeper of Maps was here earlier today. All of you out there helping our guests like Jeff get on board, helping. There's just so much going on, and all of you out there, are helping this occur. And if the hardest thing I have to do today is type in people's two-factor authentications before the tokens expire, you guys are making this easy. So thank you to all my mods and help and staff. You're what make all of this possible. And and Jeff, I want to pay it forward and help you. Please, uh, hit me up and I will get you in touch with the people who have the planet models because they mapped the planets. And
Awesome. I look forward to that.
now, with making telescopes on a 3D printer, has anyone yet 3D printed everything but the mirror?
There have been a couple small telescopes, yeah, that have been done that way. Like a couple 4.5 inch type stuff I know, but the technicians that install the big HP printers that we have, which are not even released to the world yet. They're going to be, next month or so. One of them said he was a little from a telescope. He's like, you can build parts 14 inches square. You could build everything except the optics for like a 12-inch Dobsonian if you wanted to. Like, are you challenging me to design a 3D printable 12-inch Dobsonian
Yes.
style telescope in SolidWorks and print it? Because
Go.
if you're challenging me to do that, that's the thing I will do.
I think this needs to be a thing. I think this definitely needs to be a thing.
Yeah, I mean that printer is more a plastic printer, but it is strong and it's production level. So the
Well,
3D printing guy said, yeah, if you design it correctly, it'll be stiff enough. I'm like, well, we'll
the
see.
the Galileo scopes should be completely 3D printable.
Oh, sure, absolutely.
And so you're just scaling up from that, and I'm wondering if it would make sense to basically do an open truss design where you put it together like Tinker Toys, just 3D printed Tinker Toys.
Yeah, I was kind of thinking of like an open cage, but that's printed, and it kind of like snaps onto like the secondary cage and the main tube, something like that. I'm not sure.
Yeah.
I don't really need a 12-inch telescope. I already have telescopes like that. I mean, I have a Starmaster 11-inch Dob that I use most of the time in the 22. So, from my standpoint, having another Dob, I don't need that. But from a challenge standpoint, maybe we raffle it off, maybe we give it away, maybe we do something else. If they want me to do it at the office, I'll be more than happy to do so.
That I tell me how I can help, and I'm there, and we have dogs playing loudly in the background. Um okay. So you've done podcasts, you are on Twitch, you are producing 3D printed things for your company. Do you have any one place, I'm hoping the answer is yes, where people can find all the amazing things you do?
Well, I'm AstroSets pretty much everywhere. So AstroSets on Twitter, AstroSets on Facebook. I'm most active on those platforms right now. I do have an embarrassingly out of date website, which I will be updating. But that also, if you go to astrosets.com, you'll find out where you can get me on Twitter or Facebook. But basically, if you go LinkedIn, Twitter, Facebook, anywhere, yeah, it's AstroSets. So yeah, mostly Twitter. If you're on Twitter, you can hit me up there. That's where I'm most active, and then Facebook as well these
That
days.
that sounds good. So this has been fabulous. The time passed far too quickly, but I'm afraid it is over. And I see our next guest waiting in the wings to come in. Will you hang out with
Okay.
us in the chat?
Oh, I've been here all day.
That, thank you. So thank you for being here. I am now going to swap out screens while I get things set up for our next guest. And I'm having a moment of hurry up and unfreeze. There we go. Okay. So thank you all. Thank you, Jeff, and
Thank you very
everyone.
much.
Go check out what he has. And I am providing a 2-factor authentication real fast for folks as we do a swap out of tech. Like I said, there's a whole crew of people making today's stream possible. I am just the face on camera. Everything we do really is a collaboration. And I have to give a shout out to everyone who's here. And Jeff, you are welcome to disappear when you are comfortable to disappear.
Okay.
So coming up next, we are going to be discussing the ongoing adventures of a Tesla Roadster as it makes its way on an orbit that carries it out past Mars and back again. But before we turn to that, I'm going to remind all of you that we are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are a 501c3 nonprofit dedicated to exploring our solar system and beyond. Here at CosmoQuest, we are your place to learn and do science, and we should be days away from, well, being able to bring back the science. We've been working behind the scenes with the OSIRIS-REx spacecraft to help them, well, figure out where they're going to land that little spacecraft of theirs. And now we're getting ready to invite you guys in as well. But before we get to that day, we have to get through this day. And this day is here to celebrate the 365 Days of Astronomy podcast turning 10. And 3,650 some odd podcasts later, it's time to celebrate. So we are bringing back podcaster after podcaster and catching up and seeing, well, what they're up to next. And can you scoot sideways? You're not centered, Ben. There. Okay. Now I'm going to transition you in. You're still not quite centered, but I have your face. I have your whole face. There we go. So thank you so much, Ben. And you are working on a truly amusing and delightful project that I need you to share. You are tracking a Roadster.
That is correct.
So fill our audience in on this great, amazing thing you are doing.
Can I share the screen here?
If you share the screen,
break
yes.
Okay.
Yes. Let me switch through an intermediate screen. So
That's okay.
Go ahead and share your screen, and then
Let's see here.
I can share it with everyone.
You seeing it?
Now I am. Let me just embiggen things. Got it.
So this is a website that I had created a little over a year ago when Elon Musk decided to launch his Tesla Roadster into deep space. I was trying to figure out where it was, and I figured out how I could figure it out, but I figured that a lot of people wanted to know and couldn't figure it out. So I figured, I'll put this together on a website, and it's been a lot of fun since then.
Now, you're collecting data from a variety of different places. How exactly are different people figuring out what's up with the Roadster?
Well, the primary thing that I'm doing right now for the data collected is from JPL Horizons, which is able to track most small bodies, including many asteroids and comets and stuff like that. And it, I tried to create some of the data from Elon Musk and trying to create my own source for it. But thankfully, NASA has this great organization that tracks these kind of objects using telescope measurements from a lot of people.
And so telescope measurements means there are people out there tracking the Roadster with telescopes.
There were people who are out there. Unfortunately, right now, it's a very, very small object that is a very, very long ways away. But they were able to track it for about 7 weeks after it launched.
But it's small, and it's red and not white. And,
yep.
And only so reflective.
That is correct. Although it is also attached to the upper stage of the Falcon Heavy, so it's at least white and a little bit bigger.
That's true. Now, last I heard, the Roadster was predicted to go on an elliptical orbit out past the planet Mars and then cut back towards the planet Earth, but not intersect the planet, just intersect our orbit. Does that remain true?
It'll continue to intersect Earth and Mars's orbit periodically, although it'll come fairly close to the planet Mars next year, actually, in October.
And fairly close means what?
Oh, about 500ths of an AU.
Okay.
So it's respectably close.
And And sadly, I don't think we will have anything capable of seeing it, but it's still awesome to think about.
Nope. I've done the math, and the closest that there is the HiRISE telescope. But HiRISE is a wonderful instrument for looking down at Mars. It isn't such a great instrument for looking at stars or little tiny roadsters in space.
Now, tracking objects isn't something you do with only this particular object. You have tracked other things. And can you unshare your screen and we can go
Oh,
back to a different view again?
see if I can figure out how to do that.
It's all good.
Let's try this.
So
Okay.
I am clicking through transitioning on my side as well. Um,
And that website, by the way, is whereisroadster.com. So pretty easy to remember.
okay. And there, I have us back on the screen together.
Yay.
Um, so in addition to tracking the Roadster, you have also been keeping an eye out on the fastest little spacecraft that could, and that would be New Horizons.
Sure.
Um, what all are you working on with that particular mission?
I haven't done a huge amount of work, but I found it really fascinating how they were able to track their course to 2014 MU69, that's commonly known as Ultima Thule right now. It's amazing that this tiny, tiny rock that's way out on the distant edges of the solar system, they were able to track it in part by telescopes that, quite frankly, many amateurs probably have. There's probably people in this audience who have the same types of telescopes that they were
Yeah.
able to use. And the way that they were able to do this was by tracking the shadow of it as it crossed across a couple of stars, and you were able to see just a quick dippening through it. I found this absolutely fascinating.
What was that? You just suddenly moved.
Oh no.
I'm still here. Can you hear me okay?
Yeah, I can hear you. Can you
Okay.
hear me?
Yeah, there was just a momentary glitch.
Oh,
So with all the maneuvering that New Horizons has done and still has the potential to do, this is one of the awesome things about this spacecraft is they still have enough fuel that they can potentially redirect, and my dog can hear the noise of cheers at the faintest level. We're gonna have a doggy invader again in a moment because he heard the bits, which I am
uh-oh.
grateful for, but he may actually be more grateful for. He's now searching my desk for Cheerios. Thank you, humans. Eddie, thanks to you so much. Um, so, what are you doing your own modeling? Are you using NASA eyes? What all are you up to?
I've done some just looking at some of the data and trying to figure out how it is that they can do this. One of the things that I've started is a YouTube channel to help people to understand how they are able to track some of these objects, and kind of just visualize different types of things. Um, so I've been looking into how they've been doing it, and trying to figure out how they can contribute, how they can actually do this. One of the amazing things with New Horizons is they're actually going to try to find a Kuiper Belt object and visit it, even from their own measurements, not trying to use any earthbound telescopes at all to try to track it, which is absolutely amazing to me.
And just the fact that they still have the power, the fuel, and the resources to keep going. This little spacecraft launched while Pluto was still a planet.
That is correct.
And yeah, yeah. So what's next? We have a roadster, we have a little spacecraft. What other things have caught your eye? And what was it that first brought you to 365 Days of Astronomy so long ago?
I actually watched episode one, or listened to episode one of it from long, long time ago, back when it was just starting, and have been kind of following the progress ever since then. As far as what I have next, one of the things that I've been trying to do is to not just track the spacebound, the Tesla Roadster and stuff like that, but actually every deep space mission that we've sent out, which there's just such an amazing variety of different things that are out there, and put together some kind of a video so you can just see where we've sent different objects throughout the solar system.
So, so what's your YouTube channel for people who want to find it?
YouTube.com/C/where is Roadster.
That works. Where is Roadster?
Mhm.
And you have one of the cutest icons around. I just have to say that is absolutely adorable, and your artist is to truly be commended for that amount of cuteness.
I'll have to pass the word on.
So, tracking objects is one of those super necessary things, but not a lot of people really worry about this. What first got you interested in the hows of what Pluto, the hows of what New Horizons has been able to do beyond Pluto and all the things that go into the future of the almighty Red Roadster?
It's just always, I don't know, it amazes me how precisely they're able to aim these spacecraft and to track them. And there's always the fact that someday we might have an asteroid that has its target set on Earth, and we might need to be able to do this for something a little more practical than tracking a little car through space. But it's just kind of, I don't know, always caught my interest.
And our audience is being adorable regarding Pluto. Star Song has written, "Keeping Pluto in our thoughts." Where do you come down to ask the controversial question? Where do you come down on the planet, not a planet, planet classic?
Well, Pluto is the only object that is not classified as a planet or as a moon that has a substantial atmosphere. So it acts a lot more like a planet than some of even like Mercury, even though it's smaller and it's a little bit more out there. But yeah, it's just terminology. It's an interesting object one way or another.
It's true. And I am Team Series. I will always be Team Series. And when I say Team Series, I mean that little other former planet. And I'm going to take a moment to plug, because this is a design I personally did to commemorate Pluto's well, reduction in status. This is, and I'm sorry that you can't see this, Ben, but our audience can. This is our shirt that we have up on Redbubble of Planet Pluto Classic, which is, of course, a play on the Coca-Cola Classic label. Because just like New Coke was a mistake, maybe Dwarf Planet was a mistake. So, hey, let's remember our little worlds when we can.
I like to tell people dwarf planets are planets too.
It's true. It's true. They really are. And I personally have gotten into the habit wherever I can, and I still make mistakes, of using the word world, because there are places like Europa and Titan and Ganymede, which is bigger than one of the planets. And if these moons can have dynamic geology, meteorology, and so much going on, well, let's share the same noun. Let's call them all worlds.
Sure. I mean, Titan is far more of a planet than, I mean, it has water geology on it. It's
Yes.
amazing. It
Y-
it just if you take the little fact that it has the wrong type of atmosphere, a little bit lower gravity, and it's orbiting Saturn instead of, it could kind of be like Earth. Minor details.
the one that really gets me is the way with Titan methane is at the triple point. And so you have rain, snow, ice, humidity, all of it with, instead of water, methane. And this means that when you look at the surface, you can see the river deltas like we see here on Earth. And as someone who lives near the Mississippi River, it's just like, oh, that's a very cold version of home with very little gravity. I like it here, but that's cool. And
Yeah,
yeah, the science
it,
that works here works everywhere.
you gotta love the people. I used to sit in a room right next to some of the Cassini scientists, and just seeing some of the studies that they're doing, it's amazing. even though Cassini is no longer actively contributing research, they're still doing papers on it. They're still doing papers even on the Apollo program, which just is amazing. They opened a new box of samples that hasn't been touched since they were collected from the moon just recently.
Yeah. And one of our scientists at the Planetary Science Institute is getting some of those pristine samples. And what gets me about a lot of this is as our technology advances, we can learn more and more from these samples. And because they recognize that someday in the future, great things might be possible, they set aside those samples for the future. It's just like all of the archaeological sites that we know there's so much information buried beneath the ground, but we use our side radar, we use other remote sensing techniques because once you dig something up, you can't dig it up again. Once you dice something up and put it through your electron scanning microscope, you can't do that again.
Mm-hmm.
And we are so
Amazing
grateful.
foresight for people 50 years ago. It's hard to
Yeah.
believe Apollo was 50 years ago. Apollo 11.
Yeah. Yeah. 50 years ago this summer. Are you going to be doing anything to celebrate?
I haven't decided yet. I should do something though, for sure.
Yep. And it's not too late to figure that out. I know I still haven't made my plans, but the plan making shall occur.
Got 3 months ish.
Now, the Roadster, New Horizons, these are all really new things to be happening, but you've been interested in this stuff since well before, MU-69 was anything more than an unknown glint in the stars. What first got you involved in sitting beside people on the Cassini mission?
I well, the sitting beside the Cassini mission, when I was a student at the University of Arizona, I was working with the high-rise camera around Mars.
Uh-huh.
So that had caught my interest. But truth be told, is I've been interested in space and space exploration since I was very, very young, second, third grade. I remember in third grade reading every single book that my library had about space that there was. And I think they started to get more of them. So I continued to read all of them. And it's just amazed me since then. And I've continued that passion throughout it and trying to help other people understand that kind of stuff too.
And I'm pretty sure that you're a post Apollo baby like I am,
Oh,
who,
yeah.
yeah. Now, do you look at our planned returns to the moon or not return, future first footsteps on Mars? How does that make you feel to imagine this new human era of space exploration?
I'm really, really excited to see that happen. And it's amazing to me that we're actually starting to see that kind of stuff happen. I I'm yeah, I built a website about a SpaceX launch that happened. I do kind of lean towards them and the amazing things that they're doing. They're building a ship that could go to Mars, and they're doing it in plain view of everybody with a water tower company. You
Yes,
can't make this stuff up.
I know.
It looks
It's
like a
it's
water tower, but it could go to Mars.
it's wild. And what this is ridiculous, but one of my favorite things about their Texas facility is they're not the ones providing the around the clock webcam views. There is a surf school a ways away that just the land is so flat that the surf school pointed a telephoto lens towards SpaceX, and this is how we're monitoring the mission's development.
Yeah, it's remarkably in close, and they're going to have these rather large rockets there someday. But the NASA SLS mission to get back to the moon, I think the 2024 is extremely optimistic. But at least with SLS, maybe
Yeah.
SpaceX could do it. I don't know. We'll
Yeah.
see.
The thing that makes me most sad with the space launch systems is if it does fall radically behind or if it does suddenly get canceled by Congress, what happens to the Europa Clipper? I think it's early enough in the development that they can, at little to no cost, switch over to launching on a different rocket. But right now, it's spec'd out to just fly on that SLS.
Oh, I've done the math, and they can actually launch it on Falcon Heavy, although it would be similar to the Juno mission, where it did a flyby of Earth.
Okay.
and send it out to Jupiter. But they would be able to do that. It would be about a 5 year mission as opposed to the direct path of 2.5 years. But
Yeah.
if SLS is delayed 3 years,
Might
it's
as
quicker to just,
well.
yeah, yeah,
A-
it's quicker to just launch. I can't remember the launch date offhand, but it's, 2022. They could launch it on a Falcon Heavy in their fully expendable mode, and it would be able to get there no problem.
And in many ways, going to space is all about delayed gratification. Um, one of the great examples right now is the Bepi Colombo mission on its way out to Mercury. This mission has just launched, and it won't get to Mercury until December of 2025.
Hmm.
They named this spacecraft in 1999, which means that people started working on this spacecraft well before 1999.
One thing I'd like to remind people, I found this article on space.com in 2006 or 7 that they were talking about what they're going to do with the end of life of Cassini. And of course, it ended up going into Saturn after it had a complete mission. But one of the crazy ideas that people were talking about doing was actually having it fly by Jupiter and impact Mercury at the same time that Bepi Colombo was going to be launched, which is just, it's absolutely ludicrous.
Did they have the fuel?
It actually had the fuel to be able to make it to a Jupiter flyby. And once you can fly by Jupiter, you can go anywhere in the solar system.
That's wild. I
Now, of course, they use their fuel for a lot more valuable thing than this crazy mission to launch
Science. Yeah.
but still, it's amazing that they could have done it if they really wanted to.
Wow. That is an article that if you could fly if you could find it, it would be absolutely amazing.
I'll post a link in the chat after we're done talking.
Dang. Okay. There's so many crazy ideas that people have when it comes to space exploration. What's the craziest that you've heard of other than what you just mentioned, which is now the craziest I've ever heard?
Well, one of the things that I find really interesting is the early days of the space program. One of the major goals after they had launched satellites and stuff like that was to just launch something just to hit the moon. Nothing particularly fancy, just hit something with the moon or hit a spacecraft there. And the Russians did a relatively modest spacecraft. The Americans did a much more complex one that actually took video images as they were coming down with the Ranger program. But just kind of amazes me that that's what they were trying to do. And then they were trying to figure out how can we actually prove that we hit the moon. And it turned out in the end that some independent observatories were able to do that. The Jodel telescope in the United Kingdom was able to verify this. But before that, they were talking about launching nuclear weapons just to show, hey, we hit the moon. See, you can look up and see it.
That and this all is based on science fiction in so many ways. The Jules Verne novel, the From the Earth to the Moon, is predicated on the idea of firing something big enough to be seen if you do all the physics wrong from the surface of the planet at the moon. And they came up with, you needed in their Don't Actually Understand Optics book, a 9-meter wide projectile. And I just love this idea that we eventually got to the point of, yes, we are going to fire things at the moon so that we can see them. And
yeah.
Then we bombed the moon with L-Cross because of course we did. Of course we did.
Well, there's a huge history of hitting the moon deliberately for science, including the Apollo program. A significant number of the leftover upper stages and the ascent stages after the astronauts had left were deliberately impacted on the moon, and they were able to measure it with seismometers where it hit and kind of get a better sense of what was on the inside of the moon. So there's been a long history of hitting objects on the moon for science. When the Bereshik lander did that and attempted to land, and first private mission to attempt to land on the moon, they're there somewhere.
Yeah, and they did land. It was just a bit catastrophic, and they were unable to return signal afterwards. But they landed. They did get there. And my name and my co-host Fraser's name are both on the spacecraft. Thank you so much, Ambius, out there for doing that for us.
Pretty cool. Hopefully your name is still intact.
Even if it didn't, it made it there and then self-destructed, and that's a grand way to self-destruct.
Yeah, that's a good way to look at it.
Paranor is saying in the chat, moon abuse. Well, maybe, maybe.
I like that.
So, you have a Roadster website. Do you have an MU69 website?
No, most of my interest in that has been just observing and trying to explain to people how it works. But I've just found it absolutely amazing that they're still trying to find something that they can do with their own telescope. MU69, the only telescope that could observe it until New Horizons got close enough was the Hubble Space
I
Telescope.
know, isn't that awesome?
But they were able to kind of see it with these backyard telescopes that were, half meter to a meter diameter, which is just amazing.
The catch was finding it. So the real problem, and I'm telling you things you already know, the real problem that the New Horizons team was trying to solve is they have their spacecraft. So here's the sun. I'm trying to reflect the light off of this. There's the sun. Here's their little spacecraft flying out, and they need to get to an object, trying to do this on camera, that moves into the path of their spacecraft. And at the time, they were trying to find things that would land in front of their space or orbit in front of their spacecraft. So they have this intercepting pair of trajectories. All the potential orbits had the objects in front of Sagittarius, and that is a stupidly busy part of the sky that happens to contain the center of our galaxy.
That's why they weren't able to observe it with any of the other large telescopes on Earth. Only Hubble could do that because of less light pollution.
Well, and it had so much higher resolution that it could take apart all those different objects and make them into individual objects instead of the smeary mess that many earthbound telescopes were condemned to.
Mm-hmm.
And once the object got out of Sagittarius, thank goodness things orbit, suddenly the backyard astronomers who knew where to look and knew what speed to track their telescopes at could take a look at this little object that could.
They only could see the shadow of it as it passed in front of a star, but still they were able to get a picture of it. And just based off of this little shadow, they were able to identify the shape surprisingly accurately.
Yeah.
Which is just amazing using telescopes. Now, they had high speed recording of which was able to track the shadow, but still, in the end, they were able to come within, I think, 3 kilometers of where they were targeting.
Yeah.
Just amazing accuracy.
Yeah, and space is big and empty, and things move. And
when they did the Pluto flyby, they actually went back to the original images that discovered Pluto and included them in the data arc, so that way they could get the position really, really accurately. But they had 4.5 years of history was all, and it was a much bigger data arc because it's further out in the system and moving much slower. So
yeah,
good job to the New Horizons team if they're out there.
Yeah, and this half hour has gone way too fast, but I see our next guest waiting in the rings. So one more time, where should people go to learn more about all the things that you are doing?
Sure. Whereisroadster.com to track Elon Musk Tesla Roadster, and youtube.com/c/whereisroadster for learning about space exploration.
And we are now going to transition to a moment of happy dogs eating Cheerios while I bring in our next guest.